Hello, my name is Andrei Smirnov. I'm engineering at Sidero Labs, and today I'm going to show you a small demo of KubeSpan. I'm going to use KubeSpan to join my private local Kubernetes control plane to the workers running in the public clouds. So KubeSpan is a new product which was released with the latest version of Talos 0.13. And KubeSpan allows to span clusters across different networks. Basically, KubeSpan is a way to automatically discover and configure WireGuard mesh network between Talos nodes. So as we deploy our Talos cluster, the KubeSpan will take care of discovering the endpoints and creating connections between the nodes on the WireGuard, and then routing all the node-to-node traffic through the WireGuard network. And this allows to go through the nets, firewalls, and such. So let's jump straight to the demo. That's the overview of what is going to happen today. I'm going to have my control plane running on QEMU VMs in my local home environment. Imagine that could be a data center or other on-premises environment, which is behind the net and completely firewalled from the public internet. And I'm going to launch 4 VMs, 2 VMs in AWS and 2 VMs in Google Cloud, and join them as workers to my Talos cluster. So in Kubernetes, I will have 3 master nodes and 4 workers. And also the control plane endpoint for this cluster is going to be hosted on KubeSpan itself. So it will be using a Talos feature called virtual IP, uh, which which is just simply an IP address which is managed by Talos, which is always attached to one of the control plane nodes. And this address will be only available with the KubeSpan. So of course, this address is not available on the public internet, and AWS VM wouldn't have a way to join my cluster if not KubeSpan. Let's start doing that. So to prepare for the demo, I created my VMs in QEMU. So I have 3 VMs running in QEMU, running Talos 013. They are right now don't have any machine configuration. They are waiting for the machine configuration to be submitted. And also 4 VMs in GCP and AWS combined. And let's start. These VMs are also deployed from Talos images and also waiting for the machine configuration to be submitted. So let's start. I'm going to run my small shell script, which is going to generate the machine configuration required for my cloud. And I'm going to start applying this machine configuration, starting with my control plane nodes running in my home environment. I'm going to send control plane configuration to these nodes. Actually, same configuration for all 3 VMs. And as I submit machine configuration, these VMs start booting, and they boot Talos, then they bootstrap Kubernetes. And the only thing I have to do is I have to pick one node and run the bootstrap command so that I will bootstrap the etcd cluster so that it will start building on my computer. Probably I launched this command a bit too early. The cluster is still booting. Okay, now it was right time. So now etcd bootstraps and builds the HA etcd cluster, and on top of that we'll have HA control plane with the Kube API server, controller manager, and scheduler running on all 3 nodes. And while this is happening, I can also use the Talos feature to discover my cluster state. I can do talosctl get members, and I can see the current members of the cluster. You can see 3 VMs, which are running here in my home environment, all on private IPs, and you can also see that one of the VMs, it claimed the virtual IP address. So it's actually now the node which handles the traffic for the control plane. I'm going to launch the same get members command in watch mode now. So I'm going to watch how members are added to my cluster. And I'm going to submit worker configuration to the GCP and AWS VMs. I'm going to use basically same command. So let's start with GCP first. I'm going to do apply config, insecure, and use the worker configuration this time. And as I submit this configuration to the GCP VM, it starts booting and also registers itself with the discovery service. And we can see that one of my control plane nodes immediately sees that there is a new cluster member joining from GCP. And I can keep going with this process. I can add another GCP VM now. And I'm going to do same for AWS VMs as well. These virtual machines, even though they have external public IPs attached to them so that my home environment can talk to them, they have a restricted firewall on them. So the only thing we need to keep enabled for these VMs when they are running is one single port for KubeSpan for WireGuard traffic, that single UDP port, and that the traffic on this port will be completely encrypted. And just temporarily, while I'm submitting this initial machine configuration, I have to open one TCP port just to submit this configuration. It's actually submitted encrypted, but there is no TLS verification because this node doesn't have any configuration, it doesn't have any CA. And so I submitted machine configuration to all 4 workers now. You can see that my cluster has 4 new worker members. And what I can do next, because the Kubernetes control plane should have booted up, I can fetch the kubeconfig, so to my local environment, and do kubectl get nodes. And you can see that my cluster now consists of 3 control plane nodes running in my home environment, 2 AWS VMs, one is not ready yet, it's probably still booting just for seconds since it registered, and 2 GCP VMs. I can do -O wide to show the full picture. You can see that all these VMs are running on their internal IP specific to the cloud they're running at. But nevertheless, they all build up a cluster, and the connection between them goes over KubeSpan. And for example, this KubeSpan connection not only powers the Kubernetes itself, but also powers the Talos API access. When I issue the talosctl command and I specify the node IP address, for example, this GCP node address, what is going to happen, the talosctl running on my local computer is going to talk to the control plane endpoints, which are running once again in my home environment. And these control plane machines are going to forward the actual request to the worker running in GCP. So I'm not talking directly to the worker, but rather talking to it through my control plane. And that is how the traffic is going to travel to that GCP node. Or I can do same for my AWS virtual machine, grab its private IP address. And once again, I can talk to that private address here from my local environment just by going through the control plane node, which are all part of the KubeSpan network. What else can we see doing this? We can also check the KubeSpan peer statuses, which allows us to see how the connection, the WireGuard connection between the peers was built. And for example, I launched this against one of the AWS nodes, and I can see that here on AWS, how it sees connection. These connections are, for example, coming from my local home network, and they use my external public IP of my internet service provider. And these connections coming from the Google Cloud are using Google Cloud public IPs of the VMs, and that is another connection from the AWS VM. It could have used either private or public IP. KubeSpan just tries to use all of the available endpoints, and the one which works first is going to be used. That's it for the demo today. So thanks for watching, and if you have any questions, please reach out to us at siderolabs.com on Twitter or by sending us an email. Have a great day. Thank you.